Today's talk is going to be about ZK Rollups 101. My name is David Barreto. So I'm a Starknet developer advocate. I actually work for Starkware, and I'm based in Toronto. So these are my socials and actually also my blog. So today in this talk, I'm going to cover a little bit about ZK Rollups, then talk about Cairo, which is a Starknet programming language for smart contracts, then talk about Starknet itself, some about tooling, decentralization, and if we have time, maybe questions. So let's start with the ZK rollups. So what is the issue with scaling on L1? So on Ethereum, for example, you have a block producer who collect transactions and computes a new global state. And let's say that this new state is 42. So the block producer says, okay, this is a new state after I compute all the transactions and send this message for the whole network. And then because no one is going to actually trust the block producer, every validator in the node in the network is going to actually re-execute the same transactions in the block just to verify that they get to the same result. And that's part of the consensus algorithm. So as you can see, even when you have simple transactions in a block or a small block, there's a lot of computation that the whole network has to do to get to a consensus that this is the new state of the network. When we talk about a ZK rollup, like in the case of a Starknet, the idea is that you execute only once and then you verify everywhere. So a ZK rollup not only is gonna take the transactions and compute and give you a new global state, it's also gonna give you a cryptographic proof of the validity of this computation. And that cryptographic proof is the thing that it gets sent to layer one. So now every validator executes or verify that proof to be convinced that it's actually that the new state. And the interesting thing here is that the verification of that proof takes only a fraction of the underlying computation required to create a new state. So as you can see, when you think about the network as a whole, you save a lot of processing power just by using this new mechanism that ZK rollups and particular validity proofs are able to provide. So in the case of Starks in particular, the connection between the amount of computation versus the amount of effort required to verify a proof is log square of n, or it's what's called polylogarithmic. So if the sequencer does this amount of computation, then every validator on the Ethereum network only has to do this small amount of verification to be completely convinced at a mathematical level that the new state is actually what the sequencer is claiming to be. So when you see in this chart, you can compare, for example, the blue line, if you can see colors, or the linear, y equals x, is the number of steps to execute certain transaction or certain computation, while the red line, which is the polylogarithmic, is the amount of effort to verify the associated validity proof. So you can see like the bigger the gap between these two lines get, the more gains you get in performance. So a way to think of ZK proof, one of the value proposition, is that validity proof is to computation what the zip algorithm is to file size. It's a type of compression. Just in the case of validity proofs, it's a compression of computation, while zip is a compression of file size. To talk about a little bit more about validity proofs, first of all, they are an implementation of zero knowledge proofs. That's one way you can use zero knowledge proofs. And what they do is that they guarantee what's called computational integrity. And that, a way to think about this property is that doing the right thing even when no one is looking, right? This is the sequencer doing its job off chain. And then you create this proof that by verifying it, you get complete certainty that that computation was done correctly or with integrity. So in CK rollups, the majority of them, actually all of them at this point, because Aztec is not a thing anymore, all of them are not about privacy. They are about scaling. So they use zero knowledge proofs for scaling on the Ethereum ecosystem, not for privacy, at least not yet. It will come maybe later. So you can create a CK rollup based on Stark validity proofs or SNARK validity proof. They have slightly different properties I'm going to discuss in a moment. In the case of Starknet, we actually use Starks for the basis of validity proofs. So you might have heard a lot about SNARKs And you might wonder, well, what's the difference between Starks and SNARKs? So the main difference that I mentioned before is that the verification of a proof in the case of Starks is polylogarithmic, right? The chart that I showed before. In the case of a SNARK, it's actually constant. It doesn't matter how complex the underlying computation is, the verification is always the same amount of effort. And also a big difference is in the proof size, the thing that gets sent from from layer two to layer one for verification. In the case of a Stark, and in the case of a Starknet, is in the 400 kilobytes in size, while in the case of a Snark, it's actually pretty small. It's a couple of hundreds of bytes only. So you might wonder, well, why did we bother to use a Starks and not Snarks for a Starknet? And the reason that there are two important properties of a Stark. The first of all is that when you have a system built around a Stark, you don't have to do what's called a trusted setup, right? You don't have to feed the system with a secret and make sure to dispose this secret properly. Because on a Snark, you actually need that. You need to feed a secret. And if the secret is not disposed properly, then the system is compromised. The other advantage of Stark is that it's also quantum secure. So even if a quantum computer comes online with enough power, at least that we know of, there's no way to break a Stark proof. Just because the only, let's say, cryptographic primitive that is used by Stark is just hash functions. That's the only thing. In the case of a SNARK, they are actually vulnerable for quantum computers whenever they actually come online. So those two big properties are important for security. And for us in Starknet, security is of paramount importance. If you know anything about Starknet, you might know that it's not an EVM rollup. We have our own VM called the Cairo VM. So the question is why we didn't make it EVM compatible. Well, you have some rollups which claim to be CK EVMs, and then you have something like a Starknet. Also, I think CK Single, so it has their own VM, I believe. But there are pros and cons of both approaches. So on one side, when you have ZK EVMs, what you get is compatibility, right? The idea that you can take an application that works on Ethereum and you can deploy it to a layer two, and it works for the most part. But then you lose on performance, which is what you gain with something like Cairo. And on the Starknet, with the Cairo VM, you will have to use a different programming language, in the case, the Cairo language. But what you gain is that it's a programming language that is fine-tuned for creating of validity proofs and a new type of CPU architecture. So what you get is the best performance that you can possibly have on layer twos. But you sacrifice compatibility, right? You have to write the smart contract in Cairo, or you can use a software like Warp to compile from Solidity to Cairo. There's a blog post by Vitalik that he compares different, let's say, CK EVMs, and he classifies like 4 types. And type 1 is the type of ZK EVM that you don't have to change anything, and then whatever Solidity app on Ethereum you can run there and it will work. The downside is that it's very, very slow to create a cryptographic proof. The validity proof is very slow to create. Because basically the EVM was created for a world that is not at all compatible with validity proofs and the type of architecture that is required. Then you have type 2 CK EVM, which are for the most part the same EVM. It's just they change some of the data structures used for storage, the storage of the global state, which gives you not full compatibility, but you will be able to execute most of the Solidity apps on Ethereum. But again, performance is not great. Then you have type 3 that not only modifies the storage structure, but also uses different hashes and also modifies precompiles. So now your compatibility is only partial. So when you want to deploy Solidity smart contract to that CK EVM, you will likely need to make some changes, big or small. I don't know. It will depend on what features your program uses. But again, the performance is still not great, right? Because but the EVM is not meant to be used in this way. So, well, there are 2 projects that Scroll and Hermes actually are going in this direction. But then you have the Type 4, which is a kind of a Starknet, and I think CK Sync as well, where you actually have a completely different VM, which means that you have to write your smart contract in a different language, so it's not compatible unless you consider transpiling compatibility. But then what you gain is like a much faster uh, proof creation, and which means a faster system overall. So to summarize, like why ZK rollups? First of all, they give you what's called computation compression. They are all secured by Ethereum, just with the fact that the validity proof is actually verified by every node of the layer one. So we use ZK proofs not for privacy, we use it for scaling, all of them actually. We tend to think that ZK rollup is a misnomer because there's a assumption that has to do with privacy, but in reality, it's about scaling. So we like the term more validity rollup, and that's what we use to describe Starknet in particular. So as I mentioned, you can create validity rollup using either Starks or SNARKs. I discussed some of the pros and cons. And in the case of Starknet, we actually use Stark proofs, which are fast and are safe, quantum secure, and don't require a trusted setup. So let me talk about the actual programming language that we use on Starknet, Cairo. So Cairo was released in 2020, at least the first version of Cairo, which we call Cairo 0.x or Cairo 0. It was the first provable programming language where a language is able to create a validity proof out of its execution. And it can be used actually outside of the blockchain. That you can use like vanilla Cairo for any type of program. Doesn't need to be a smart contract, but of course the regular use is just smart contracts on a Starknet. But it has some downside, right? This first version of the language was pretty low level, which means that it had a steep learning curve because you have to be aware of some of the internals of how the virtual machine for Cairo worked. And it was unable to create validity proofs out of failed executions. This was a big deal that we always knew. And because you cannot create a proof of a failed execution, it means that the sequencer was not compensated if a transaction failed, which as you can see this is a vector for a denial of service attack. So that's why we came up. Before I show you Cairo 1, let me show you. This is how Cairo, still look like or used to look like, just to have an idea. This is how you define a file to be a Starknet smart contract. This is how you make imports, very similar to Python. This is how you define functions to have certain special purpose. So for example, this one is to have a storage variable. The native type of Cairo is actually failed because of field element is not actually uint, as in the case of Solidity. And this is actually because of how the CPU architecture of the Cairo VM actually is. Then you have a constructor, which is called during deployment. And then you have a thing called implicit arguments. It's part of the steep learning curve that I was talking about, like knowing that you have actually regular arguments and implicit arguments. Again, you don't have to learn anything like that because we have a new version of the language that is much easier to use. But I just want you to have an idea of how it used to look like. And this is how you define read-only functions and actually write functions where you actually pay gas fees, right? So this is Cairo 0. But then because of all these limitations that I mentioned before, we actually came up with Cairo 1. And Cairo 1 is a much high-level language, which means that it's easier to learn. Its syntax is actually inspired by Rust, which makes it a strongly typed language as well. Now, Cairo 1, when you compile it, you don't compile it directly to Cairo assembly, which is the code that it runs the Cairo VM. It's actually compiled to an intermediate language that we call Sierra. And Sierra stands for Safe Intermediate Representation. And this is what allows now that even if a program fails, let's say a transaction fails, we are still able to generate a validity proof out of its execution. So now we can allow transactions to be reverted. And because now they're allowed, they can be reverted, the sequencer is always compensated for its work, even when executing a failed transaction, which means that no more potential denial of service vector. And this is how Cairo 1 looks like. And this is what you will use. Actually, starting yesterday was enabled untested Cairo 1 that you can actually use and deploy. You can see it looks a lot like Rust, and you can do some meta programming with attributes. This is how you bring functions into scope. You can use a struct to define all the storage variables. Failed steals is the native data type, but now you have other data types that are natively supported, like U256, which is what you use in Solidity, or things like contract address. This is how you write to storage. This is how you read from storage, just so you have an idea how it looks like and how similar it actually looks to Rust, which makes it much easier to learn, especially if you actually know Rust at this point. So the question is, okay, how do we go from Cairo 0 to Cairo 1, right? So as I mentioned, in Cairo 0, we cannot prove failed transactions. So what it means that eventually we need to disable all the smart contracts written in Cairo 1, sorry, written in Cairo 0, because they open the gate for denial of service. So what we're doing is that we have two important events in time. One is going to be the release of what's called a Starknet 0.11 to mainnet, which is going to actually enable Cairo 1 to be deployed to mainnet. And then we're going to have Regenesis, which is going to be a hard fork. It's the moment that we disable any old smart contract within Cairo 0 that has not been migrated to Cairo 1. So up until this point, which is the case now on mainnet, mainnet only supports Cairo 0, 0.10, which is the latest version of Cairo 0x. Now you can actually deploy Cairo 1 to test it, but not to mainnet yet. Eventually, when we deploy to mainnet, now Cairo 0 and Cairo 1, both are going to be supported for a few months, for example. And after Regenesis, only Cairo 1 smart contracts are going to be supported. So during this time, we're going to have a migration window that where we provide a mechanism, especially a syscall, that you can use to actually upgrade your code without modifying your address or your storage. So you can do an upgrade in a way that is completely transparent to your end users. And the way you will be now using Cairo 1 and you will be supported moving forward in the future. And you will have a much nicer language to play with anyway. So this is where we are right now. Just maybe in a week or so, that's when we expect, based on the vote of the Starknet Foundation, that we're going to deploy Starknet 0.11 to mainnet, and now we will be able to deploy Cairo 1 on mainnet as well. So just to summarize, so Cairo 0 is a low-level language. Cairo 1 is a high-level language inspired by Rust. Sierra allows for reverted transactions, closing the denial of service loop. We allow for a mechanism to upgrade your smart contracts while preserving your state and your address, which is also important. And Starknet support for Cairo 1 soon on mainnet, already available on testnet today if you want to give it a try. So Regenesis will not remove but disable all Cairo 0 from being executed. Okay, so that's Cairo. Now let's talk about Starknet as a system as a whole. So let's take a look at the architecture. So Starknet is what's called like an off-chain component, right? But actually uses Ethereum for security. So when you create transactions, those transactions are sent what's called the sequencer, which runs a special software called the Starknet OS. And the sequencer is the one that takes the transactions, verify the signature, and execute them and put them into blocks and execute the block to create a new state of the network. As a result of that execution of transactions in a block, an execution trace is created, and that thing is sent to the prover, which in our case we call it sharp because of shared prover. And it takes the execution trace and generates the validity proof that we actually send now to layer 1, as we send it as cold data. And now we have a solidity verifier that takes that proof and actually verify the integrity of the computation done by the sequencer. Once the verifier says, okay, this is correct, now the sequencer sends the changes of state on L2 and send that as cold data to a smart contract called Starknet Core. Basically, this is the data availability part, right? That will be allow Ethereum to track what is the latest state of the layer 1. So we don't send every single transaction, only the things that change in the state between a moment in time and when the validity proof is verified on layer 1. So we have also full nodes, which are particular to Starknet. And right now, they actually sync to the latest state from the sequencer. But the idea is that because we're using layer 1 as a data availability, you can actually, in case of an emergency, you can recreate the latest state of layer 2 just by indexing data from Starknet Core. Another feature of Starknet is that we have native account abstraction, which is different from what it was enabled on Ethereum recently. Because on Ethereum, you have externally on account, and then you can have also smart contracts implemented as, wallets implemented as smart contract. But I'm not really up to speed with the new changes for Ethereum, but I think that Ethereum had introduced a third way to create a wallet using account abstraction. So now on Ethereum you have three ways to to have wallets: EOAs, regular smart contracts, and then some kind of account abstraction. Which might be a little confusing. And the goal eventually is to have just account abstraction, but that might take a while. In the case of Starknet, every single account, every single wallet is actually implemented using account abstraction, which means that now you can use any type of elliptic curve to sign transactions. You're not limited to the curve used by Ethereum, which means that now it opens the door to sign transactions even with the elliptic curve supported by your smartphone or your devices, which might be different. And so these are some of the benefits of account abstraction. The one that I like the most is that now you can use the special hardware on your phone and in your laptop that they have for cryptography, because now you can store, save, create, store, and use the keys that your phone creates in the secure enclave or trusted zone or whatever is the name is of the secure hardware within your system. And also you can sign transactions directly with hardware, which gives you a much higher level of security, very close to the level of a cold storage like a ledger, but now just using your phone. But also enable things like, for example, social recovery of accounts, having session keys for gaming, so you don't have to sign every transaction that you do while you play. You can have services connected to your wallet that do like fraud monitoring to prevent you from being the victim of a scam, or having like spending limits in case your phone gets stolen, so not all your phones get stolen. You can do things like multi-calls, right? Instead of signing 3 transactions in a sequence, you can send a bundle of transactions and they all get executed in sequence in a single block, and you only pay fees once. Another thing important is compare time to finality. It all depends how do you calculate when things are final. But on Ethereum, you assume that in about 6 minutes you have finality. In optimistic rollup is about a week. Now, the time that it takes for a validity proof from the moment you send a transaction to layer 2 to the moment that the associated validity proof gets verified on layer 1, it takes about 10 hours. It doesn't mean that you have to wait 10 hours to get confirmation. We have other mechanisms to get, say, faster or earlier confirmation directly from the sequencer. But if you want to have the biggest or the highest safety standards that you can have on a Starknet, then you will wait until the proof is verified on layer 1. But some apps might decide to actually get confirmations earlier directly from the sequencer, and that might happen in a matter of minutes. Other features that I haven't discussed here in detail, we have what's called a trustless bridge that uses the same validity proof technology that allows smart contracts on layer 1 and L2 to communicate. They actually can send messages back and forth. We implemented what's called optimistic parallelization on the sequencer to speed up how many transactions we can bundle or improve the TPS. We have, very importantly, recursive proofs, because prover are notoriously for the amount of resources that they require to operate. So recursive proof allows to decrease the amount of resources required, which is going to be important for decentralization, and also important for it reduces latency. These 10 hours can be reduced to even less with recursive proofs. Okay, section 4. Now, let me show you a little bit of the tools that we have available on Starknet. So to begin with, we have 2 main wallets. We have Argent, we have Bravos. Argent and Bravos both have, similar to MetaMask, like a browser extension that you can use. In the case of Bravos, they also have a mobile wallet that takes advantage of what I mentioned on account abstraction and the extra security that it gives you. We have 2 different block explorers. We have Voyager and we have a Stark Scan. Both are good. Then we have tools for developers. For example, Protostar is a tool used for deploying, for testing. And the nice thing that Protostar allows is to test your Cairo smart contract using Cairo, similar to what Foundry does for Solidity as well. And with Open Zeppelin, we also have smart contracts created by them. And also they have the contract wizard for Cairo smart contract that you can use to very quickly create ERC20, ERC721 smart contracts just by a UI. And then other tools, we have a plugin for Hardhat if you want to test with JavaScript. We have a DevNet similar to Ganache if you want to run it locally. We have a library for React, so you can use custom hooks. We have SDKs for JavaScript, actually TypeScript, Python, Java, Kotlin, Scala, and iOS. So you can build your app in pretty much any platform you can think of and talk to Starknet. And the last section is decentralization. So the roadmap right now for the sequencer today, it's centralized. We only have one sequencer, which is operated by us, by Starkware. It is written in Python. But now what we're doing right now is doing a full rewrite of the sequencer in Rust to improve its performance. Actually, this new version is being released as open source using the 2.0, the Apache 2.0 license. And the first module to be released is called a blockifier. So we're releasing module by module until we complete the whole sequencer. And we now working on the consensus mechanism that we can use to have a decentralized layer of sequencers as well. In the case of the full node, we have three different versions, Papyrus, Pathfinder, and Junio, created by three different teams. Two of them in Rust, one in Go, all of them open source. And right now, I think all of them synchronized from the sequencer. What is being worked on or in research is to have a P2P network so nodes can synchronize out of each other as well and not depend on a single sequencer. In the case of the prover, is centralized, is operated by Starkware. Well, we made an open source commitment back in Starkware sessions in Tel Aviv. So this is going to be the last piece of the puzzle to be completely decentralized because it's the most complex one. The prover is going to be a challenge for any CKE rollup to decentralize. Finally, the verifier on layer one, right now it's available. It's just a Solidity smart contract, so it's completely open source. You can find it. The Starknet Foundation, it already exists, was created last year in November. It has a board of 7 members, and the goal is to make a Starknet a public good. And it has a little more than half of the initial supply of the Stark token, which is going to be used, for research and all the things that foundations need to advance and improve as Starknet as time goes by. And it is that token holders can vote or delegate their vote to decide on protocol changes. And the first vote is happening right now. You can go to Snapshot, and we have a voting ongoing to see if people want to deploy whatever we deploy right now to testnet, Starknet 011, if they're willing to deploy as well to mainnet. So you can go check it out, the vote there. And that's it. I was told that was a little like a 15, 20 minutes. I hope I didn't go too long. Thank you very much. I don't know if you have any time for questions, but that's all I have for you today.
Yeah, I think we have some time for some questions. So does anyone has any question?
Can you hear me?
Yeah.
Yeah. So I have a question about the migration from to Cairo 1.0. So you said that there will be some time for the developers, I guess, to update their contracts. And like as we know, updating contracts is kind of a no like anti-pattern. How are you willing to do that? Like to make sure there are no security problems introduced in this process.
Let's see, anti-pattern you mean because it's like what do you have a smart contract if you can update it? I agree. I don't like a smart contract when you can update them because it changes the rules sometimes without any prior notice. Let's say that right now we went that route because it's still in the early stages of a Starknet, and we needed a way to, keep the network evolving and trying out without breaking everything. But the good thing is that you can actually upgrade. When you do the upgrade from Cairo 0 to Cairo 1, you can upgrade to a smart contracts that is no longer upgradable. Because that you can do that also with Solidity. You can have the proxy pattern, and when you upgrade to the next version, you can remove the ability to keep upgrading. So that's one path. But now with this migration, we introduce a syscall to do the migration that we are discussing, and we want to keep it moving forward. instead of the proxy pattern. And that's still in discussion. But I agree. I think after Regenesis, for me, the best is to stop this ability to upgrade, and you can do that on your own when you do the upgrade. The new version can remove the ability to keep upgrade even further than that.
Okay, thank you.
Any other question? Okay.
Hey David, thanks for the presentation. And so let's assume that I want to move from Solidity to Cairo, and and I have this specific need, and that I have an indexer that it's run on my server, and it's written in Rust, incidentally. And what would be the best way to approach it, to rewrite it to index Starknet contracts, to run a full node and use its API, or what would you suggest? Or maybe there's SDK in the
We do have an indexer right now, but I guess the question is that you want to build your own, right?
Yeah.
Right. Right now, to build the indexer, you can follow two different paths. Right now, you can actually talk to the sequencer and get the sequencer has like a REST API that you can use and get data from there and just index what you're interested in. The other path is to read directly from layer one, right? So you can, like in the case of the full node, you can replace this with an indexer, and you can either be having the latest state from the sequencer directly or from a Starknet core. It's just there's gonna be a delay of 10 hours between the two of them, right? But that's one way you can do it, and that's why we actually have one indexer right now that you can use. But to build one, you have those two options.
Okay, and your indexer is like free of charge currently, or?
Yeah, right now. I don't think it's gonna be like that all the time, but for now it is.
All right, thank you.
Cool. Anybody else? Okay, so we'll be going for the next presentation.
Yeah, thanks, David, very much.
Thank you very much.
Thank
See you,
you.
man.
Take care.
Hello.